open the notes. I'm going to start here. Cool. So I don't normally actually have time to cover this, but because of the weird Thanksgiving break shenanigans, we did. So last week, you should have watched the video on mediation or regular regression, all the outlier stuff, so you get a chance to practice that and ask all of your questions in lab this week. And so the lab will cover your, I think, moderation, and the homework covers mediation to kind of keep it not so crazy long. The test will open next week, and it will cover correlation, regression, and EFA. Okay, so we've got one real lecture after today left. Ooh, so you're close. Don't forget to work on your test revisions. I think the easiest way, I know some of you have already emailed me, but if you want to resubmit those underneath the one it goes with, so if you're doing exam 2 take home, just resubmit it. It'll tell you it's late, that's fine. That makes it a little easier for us to grade and actually put in an updated score for you.
And how do, can we use our
Yes, use your notes. Yes. You should get them all right, hopefully. Yes. Yeah, definitely. The only thing you shouldn't do is just don't copy the notes. So just write it down. I know this should be obvious, but we've had problems. So okay, so getting into regression to mediation now. So these are really two special types of regression. And so mainly what the test will focus on is hierarchical regression for that lecture. So step 1, step 2, step 3. And then there will be mediation moderation questions, but probably not an analysis to kind of keep it on the shorter end during finals. Okay. So the last test was definitely the longest one. But mediation itself, we're really what you do with mediation is you're looking for the third variable problem. Okay, you can think about this as the third wheel. So it's the relationship between some predictor and some outcome can actually be explained by some other third variable. And it's really also a test, bless you, for suppression. So what happens when you have two correlated predictors? Draw a traditional model. So some x to some y. We're going to see what happens when we throw m in there. So this triangle diagram, you'll see it a bunch of times, is really popular. It's the way that people tend to visualize mediation. So we have some sort of predictor to an outcome. So we think that x predicts y, and that path is called C. That's when only x is in the equation. But we also actually really think that maybe it's not x to y, maybe it's x to m to y. So what we're really doing is predicting a different path. So we're rerouting the relationship. So you can think about this as row construction, which was all week. So much row construction. Okay. So we're also going to figure out if A and B, the paths from x to m and then m to y, change the relationship of C. So the point of mediation is to see if there is a difference between C and C prime. So essentially this, C is not equal to C prime. But it confuses people sometimes because the way you test if C and C prime are different is you don't directly compare them. You test if A and B are changing the relationship of C. So this A and B thing is called the indirect effect. So how much I've taken C and rerouted it through A and B. So we're going to talk about the traditional way that people do this and then some of the newer ways that people do this. Because I don't think you can understand mediation if you don't understand Barron and Kinney. Okay, it's one of the most well-cited statistical procedures. This number that I have on the bottom of the slide, I think was from when I did this set of notes many moons ago. So it's probably even higher now. Okay. And so the traditional structure of this was to calculate 3 regressions, but 4 steps. Okay. And so we would first take x and predict y. X predicting y. Okay. Or we can write this in R format, y tilde x. If you want. And there's some question over whether or not this has to be significant. So this is the C path. traditionally people would say it has to be significant because if you're saying that the relationship between x and y is eliminated by adding m, you're implying that it was there to begin with. Newer people think if you're talking about x and the relationship is changed, then C doesn't have to be significant. So I feel like the answer is sort of like, does it need to be significant? It kind of depends on how you're thinking about it. So if you think x predicts y and m changes that or decreases it or gets rid of it, then C probably needs to be significant. Okay? If you think that m just changes the relationship between x and y, maybe it goes from being non-significant to negative, then I would say C doesn't need to be significant. Step 2, so we're going to do the A path, where we're using x to predict m, or if you want to write this in our format, like x tilde m. I would say A probably needs to be significant. If I'm telling you that the relationship is not x to y, instead it's x to m to y, it would be a little weird if x didn't predict m, because that means that there's no rerouting happening. Now we've talked all year about p-values and significance. It might be that it's not like traditionally alpha significant, but instead you think the predictor is large enough, right? Or you're looking at the effect size of x to m, because you can still calculate PR squared here. So I'm using the word significant, meaning I have a large enough sample and I'm defining that however I want to. Okay. Last step is one regression equation but two questions. So we're going to do x plus m predicting y. The m part is the B path. And the x part is C prime. So we'll use x and m together in the equation. So we put both people in the same room and we see what happens with x to y. So we want B to be significant here because we're still working down this redirected, my row construction example. Okay. Like if you haven't driven through St. Louis lately, you don't realize that I-55 is closed. Yeah. Where are we going? We're like in the ghetto part of St. Louis. But this would be the reroute of I-64. We would need that to still be open. Okay. But then the sort of key last component is if C and C prime are different. So here in this step, C might still be significant, it might not be significant. We don't really care so much about that one significance level. More we're interested if A and B indicate that C is different. And so that's what this slide says, only in words instead of symbols. Okay. The original argument was that the C had to be significant. I would say now that people are leaning kind of towards it doesn't necessarily have to be significant. But 2 and 3 are still pretty strong. You really need your x variable to predict m, however you're defining that, and m to predict y. And that last variable should somehow change. Traditionally, in mediation, that means closer to 0. So it says less strongly. Because if you have a -1, less strongly would be closer to 0, right, and not more negative. Sometimes what you'll see happen is that C and C prime are different, but C prime got bigger. So C might be 0.2 and C prime might be 0.4. That'll indicate that there is a significant change. It's not really in the right direction. When that happens, I tend to suggest to people that they try moderation, which is the second analysis we're going to cover, if that one theoretically makes sense. which implies there's an interaction, not a redirection. So we want C prime to be closer to 0. Right. So some limitations to this idea. I would say there's like very big fields on exploring how mediation works and if we should even use mediation, because really it's just an analysis of correlated correlations. Right. So we're seeing if the correlation between X and M and Y is enough to make X and Y go away. So it's actually kind of an analysis of partial correlations. You're trying to predict suppression, basically, where adding M gets rid of X to Y. And so one of the big things is like how much do we have to make C go down for us to consider that mediation? So this has been heavily criticized for looking for changes in levels of significance, which we've talked about all year being problematic. So instead of really focusing on the p-values, we're going to do two things. One of them which is traditional and one of them which is new. So we're going to do the Sobel test. And we're going to do the A version of it. I have no idea how to say this. Erin? I'm not sure. I butchered it probably. So there's the traditional Sobel test, but we're going to do this version that corrects for the sort of correlated error of A and B. And I would say if you're going to do the Sobel, this is the most common version of it. But everybody calls it the Sobel test. So if that is significant, then we can say that mediation has occurred. All right. Or the more popular version is to use bootstrapping. Bootstrapping, it used to be really difficult. I mean, the Sobel test is from the 80s. Bootstrapping, you would have had to like manually do that unless you were just really good at programming. Now, not so difficult. If you're using SPSS, there's a plugin for it that makes it easy. And then what I've given you guys today in your R code is an example of how to make this work. But what is bootstrapping, since we've never talked about it this year? It's where you take your data and you create lots of new samples. So we're going to run 1,000 samples. So if you have an older computer, this may run slower than the newer computers. And it takes and creates little mini data sets. And the key here that I have highlighted is with replacement. So let's say you have 20 people. It's going to create a data set of 20 people, but every time it picks somebody, it puts them back. So people can be selected multiple times. It's a little bit like the lottery if they put the balls back every single time. So you could get 2 of participant number 6. You could get 5 of participant number 6. And the idea behind that is that these people are supposed to be representative of your population, so there's probably more people like them. Some people see bootstrapping as the solution to small samples. I think that's a really bad thing to think. Right? If I have a small sample, I'll just bootstrap and my answer will be better. You still have a small sample. So bootstrapping is really handy for creating a confidence interval of what we might expect to find in our mediation, but it does not solve power problems. All right. So the most popular plugin for this, like hands down by and far, is Andrew Hayes at Ohio State has a really cool plugin called Process. It's really cool. It does a lot of cool stuff, but we're going to mimic that in R. So essentially, I've tested what we're doing versus his and gotten the same answer. So if someone asks you, oh, you could do the process way, that's what we're doing. Okay. So it's going to allow us to estimate a confidence interval around our indirect effect. So remember, the indirect effect is the mediation effect. And really, if that confidence interval does not cross 0, so not positive and negative, that implies that there's a significant change or mediation has occurred. I would say this is probably the most popular way. Well, Sobel is really popular, 50-50. Because the plugin has made it very much easier to do this. The tricky part is when the Sobel test is not significant, but the confidence interval doesn't cross 0. So when people ask me questions on my YouTube channel, that is one of the biggest ones. They don't agree, and I'm like, pick. I don't. Do you like p-values better? You like confidence intervals better? I don't know. Present both and see what other people think. Okay, so I'm going to call these stages and not steps, because last week we talked about model steps, hierarchical, step 1, step 2, step 3. But that's not how this works. So people talk about the Barron and Kinney steps, but you'll notice it's not really a hierarchical regression. So we're not going to test the models against each other to see if the addition of variables added more to the equation. We're testing the paths themselves. So we're going to kind of do this as stages to not confuse it with hierarchical regression. But how does this change data screening? So for mediation, you're going to screen the IV and the mediator. So you're actually going to screen this last model. I don't think I have you guys doing this in your homework, but this is a little more FYI. If you wanted to do data screening with Leverage and Cooks and Mahalanobis, you're going to screen the last model, because then you'll get all 3 of the variables in at once. You could also go back to the beginning of the year and do that fake regression and just do them across all of them, ignoring which one's the DV. I think doing the real regression, assuming Y is the DV, is the best bet because of Cooks and Leverage. All right. Also, if you're going to do power on the last model. So that's just like the end of the regression notes. You'd have 2 predictors. All right, so we're going to do, I don't remember what the example is. I did these notes at the beginning of the week. So, but how I report this is I can make a table of those coefficients, or you can just write them out in the write-up. And generally people put in figures. So here's one from a recent submission for publication. Oddly enough, on the same day that we're doing faculty evals. So they have that question at the very end of the eval about what grade do you expect to make in this course. I think it's 15. We used that to predict the overall rating of the course. They're very exciting. This course was in the top 20% of classes. What does that even measure? It's a useless question. Okay. And we thought that students' perceptions of perceived grading, the assignments were fair, the grades were fair, so the questions about the grading system. So we used expected grade as our X, perceived grading as M, and overall rating as Y. And what we found is that across actually different types of instructors, you get different relationships for these. So we have mediation for all 4 types of instructors. So we've got graduate students, per course faculty, full-time instructors like Tanya. It's not just her though, and full-time faculty like me. What we find is that the faculty have like the smallest amount of mediation. Okay. So students are really essentially nicer to graduate students, and they're more harsh on the full-time faculty. What we're able to show is that perceived grading is more what the relationship is about, less than if you get an A, you're going to say this class is good. And I'd really actually like to redo this and look at specific types of courses, because if you teach stats and research methods, your course grades, your evals are always different. Right? This is a course I wanted to take. It's always down here at the bottom. So we have a plot in our eval system. We have this plot where you can see you versus everybody who teaches that course versus like sort of everything. And it's like no. It always goes way down. Because you don't expect students to necessarily say they want to take, stats and research methods. This is a course I was forced to take, right? So this is an example of we did a moderated mediation model where we crammed both of these analyses together. But this is what a table might look like, and the table actually continues on for the rest of the page. I'll just jump off the bottom. So we reported the B value. So the one thing not to get confused about here is that we're calling this A, B, and C paths. Remember coefficient B. So it's always called B, as in the slope, even if it's the A path. So you say the A path is B equals. Okay. So that can get a little confusing for people. Remember that B here implies coefficient and not B path. All right. So does Facebook usage mediate the relationship between some previous knowledge and your exam score? So this is some made-up data. So what we're going to do, fill this in here. So does Facebook mediate, so I'm going to stick that bad boy here, the relationship between previous knowledge and exams? So when you're reading one of these, it says, does such and such mediate? That means that that one's in. Okay, so let's look at this in Studio over here. Okay, so we're going back to importing SPSS data. Remember, that's the Haven library. And so data screening would normally go here. I have one missing data point for some reason, so I'm just going to exclude it. That would normally happen during data screening, right? You would eliminate missing data because there's too many points or whatever criteria you're using. Right now, I'm just going to get rid of it so we can run this example. So these are various simple linear models. Okay. So we're going to have for model 1, so I'm just going to call this model 1 for stage 1, so to speak. It's going to be our C path. So we're going to say our exam is predicted by previous knowledge. Right, so we've got y tilde x. And we're going to look at that bad boy, which I have over here. So our previous knowledge does predict our exam scores. I would hope so. So C here is 0.32. And I wrote an example of how this would look when you do a write-up at the bottom. So one thing people often ignore in this is the overall model. So last week we talked about, or last video, we talked about the overall model, F, blah, 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 R squared. And then you talk about the predictors, P and T. On mediation models, people tend to skip the Fs because you're way more interested in the paths themselves instead of the overall statistics. And when you only have one predictor, F and T say the same thing. All right, so we consider the significance of for every previous experience score, you had your exam score goes up 0.3 points. Now this code's going to run through what we have in R. I'm just going to look at it here because it's a little easier. What we'll have next is from model 2, we'll switch the DV. So only the DV. So we've got previous, I'm sorry, not previous. R, wait, did I do that right? Yes, previous, sorry. It's predicting Facebook now. So we switched Y out for M. And our A path is small, but significant. Like a negative 0.09. So for all of your previous knowledge, you're spending less time on Facebook. Last stage, we're going to add in B and C prime. So we're going to do X plus M to Y. So we've got Y tilde X plus M. And be sure you do X plus M in that order for reasons we'll get to in the bootstrapping. But keep X and M in order. So here I've got the B path first. So Facebook does predict an exam score. So the more time you spend on Facebook, I gotta update this example probably, right? The more time you spend on Snapchat and Instagram, guilty, the lower your exam score. So far everything's good. Right? We've got a nice C path. I would say that this, significant or not, is a pretty good effect. Right? A and B are both significant using P less than 0.05. But now I'm really interested in what happened when I added M. So how did C change when M was added? And it's still significant. So the old way of looking at this would be as if Sobel worked out, then this would be considered partial mediation. So if you ever see the phrase partial mediation in someone's writing, what they meant was that C was still significant. Ugh, we couldn't make it not significant. Which to me means you don't know how to cheat. Which is probably a good thing. But here, I don't care if it's partial. I just want to know how big is that mediation effect. So we're going to calculate the indirect effect, which in a simple mediation model is actually like the difference between the two, or multiply these two together. And so I just included some interpretations here. So previous experience positively impacts exam scores. That's our CPAth. Previous experience negatively impacts Facebook time. You're spending less time online. Now, this is the important part of this one. So controlling for previous experience. That B path is controlling for X. Facebook time negatively impacts Facebook's exam scores. And then the other way, controlling for M, Facebook scores. So controlling for Facebook scores, previous experience positively still impacts exam scores, but now the question is 0.32 dropping to 0.26 mediation? So did mediation happen? Coffee. So the way the Sobel test works is we're going to take that indirect effect, which is A times B, so we're going to do 0.09 times 0.61, and divide by the standard error of the indirect effect. Now the way that standard error is calculated is like really long, and I don't know, it's super important that you know the formula, but I really wanted you to notice that that is the same thing we've been doing all year. Good variance versus bad variance. So a ratio of the odds of this happening, basically, right? So how big is the indirect effect versus its standard error? And that gives me a Z score. Instead of T, we're doing Z. So it's still a ratio of good variance to bad variance. So if our indirect effect is larger than the error, we would conclude mediation had happened. All right, so let's look at those codes. I know it looks scary on the side here. So I'm going to make sure I ran all my models. And this code here under the Sobel section is why you need to make sure they don't change the order of anything. Oh. I thought that was like your phone going off, and I was like,
no, excuse me.
What's happening? No.
No. Got up. I was like, what the heck?
I know. Where's this emeritus faculty wandering the hall, right? Okay, that distraction aside. All right, so don't change the order of anything, because what I've done here in this fancy code is just tell it which number to pull. All right, so when we look at a summary of Model 2, specifically, so let me make this bigger. Ooh, Model 2. Right, you guys are used to looking at this kind of output, and you could say, okay, I need this number right here, this estimate, negative 0.09. The coef function just shows me the coefficients. Okay. So it just pulls the estimate here, B. And then I want the second one, because we don't want the intercept. So what that code is doing is pulling only the number that we're interested in, but let's say you change the order. On X and M, you're going to use the wrong number. Okay. All right, so I got A, I got B, I got my standard error of A and my standard error of B, which looks really scary, but this just tells it to pull the standard error column of both of those. Okay. And to me, the worst looking thing is this is Z-score, which is the formula for the Sobel test with the correction for the standard error at the bottom. Okay. So what's different between the Sobel, the normal Sobel test, and the one we're doing, since I can't pronounce it, is this this correlated error issue. So it does not assume that the standard errors of these two things are unrelated, basically. So all that aside, let's see what the Z-score actually is. Okay. So I got a z-score of 0.71. That is like not likely to be significant because we think about z, 1.96 is the 0.05 range. So this mediation effect is only not even a whole standard deviation away from 0. We can tag the p-value on this. So our expected p-value traditional null hypothesis testing is 0.49. So that's not even, like, people couldn't even say the word trending. Okay? It's not even close. So we could report it like this. It's really tiny, sorry, over here. And we would say that no mediation has occurred. Mediation models are hard to make work. I think the homework works. But this is not a big enough change. Now, for bootstrapping, you will need to install the boot library, because that's probably not one you already have. I think Will be the only one, because I made him do some of this. He got tortured already. So while you get that library installed, I'll kind of explain to you what happens. The way it works, now this can do for anything. Means, I think we did for means and standard deviations, you do this for t-tests, you can bootstrap anything. What we're going to do, while it looks a little like code, right? As we're writing our own function. You've written your own function before for the percent missing. But what happens is this first line here, d equals data set, that tells it to randomize the data set by row. So whatever data set that you tell it to use, it's going to take the data and just scramble it by row. Not like by participant or anything, your data is still your data, but it just scrambles the order of the rows. And what that allows it to do is pick a different data set every time it runs. Okay. So if you don't use a line like that, it will run the same data set every single time and you won't get any confidence intervals and you'll be very confused. Me, when I was learning this. Okay. So you have to have some sort of way of randomizing the data set. And then these should look familiar. Model 2 and Model 3, that's going to be stage 2 and 3. So this here. And then I repeated our coefficient numbers, A and B. And it's just going to return that indirect. So all it's doing is returning this, the multiplication of A and B. Because we're not bootstrapping the Sobel test, we're just bootstrapping the indirect effect itself. So essentially, don't change this. Here's what it does. Don't touch it. Okay. What you're going to do, and this is where boot comes in, is change everything I have highlighted here, or italicized. Okay. So we're going to use the boot function. We're going to say data equals master, no out, whatever data set you got going at this point. Our statistic is we're calculating indirect saved. So sometimes you can use just the word mean here, but we're calculating a special statistic. Okay. Formula 2 and Formula 3, you're going to cut and paste from where you ran step 2 and step 3. So no quotes, just cut and paste. Here we've got m tilde x and y tilde x plus m. Be sure x plus m stays in that order. So you're going to take your code you ran up here and just move it down here. Now this last line, r equals 1,000, that tells it how many times to repeat. I wish they hadn't used capitalized R, which would have been like repeat or something, or run. But that just says how many times we're going to run it. 1,000 is the most common. All right. So let's see what that looks like over here. All right. So we can calculate the total direct and indirect effects here. Total is C. Direct is C prime. Indirect is A times B. You'll also notice that the indirect in this type of model is C minus C prime. Okay, they work out to be the same. All right, so don't change this part as it says. Okay, we're just going to run it. Open the boot library because otherwise this won't run. And you'll see here I just changed the name of the data set and these two formulas. We'll see how good this computer is. Oh, it's not too slow. So depending on how complex your boot is, your function that you're running is how slow this is going to run, or how old your computer is. If you have trouble in your homework, just knock it down to 100, just so you get the idea of what's happening. Now we saved that as boot results, so I'm going to run boot results so I can look at it. Put it over here so you can see it a little bigger. So it gave me the original. This is the number I'm looking for here. That's the indirect effect. So my indirect effect is 0.05 or 0.06 if I round up, which is that subtraction here. The bias is like how off it thinks it's, the estimation's going to be. And we actually get a standard error for that as well. So I have an estimated standard error for the bootstrap effect. I cut out the code here. I didn't mean to do that. Get back. To get the confidence interval, the function is boot.ci. This is still part of the boot library. You put in the name of your results, so boot result. Confidence interval 0.95, so we're reduced to 95% confidence intervals, and type equals norm gets me normal ones, so it's even on each side. We run that, and that's not what I wanted. There we go. It gives me the confidence interval. One of them is negative and one of them is positive. So we would conclude that mediation hadn't happened because the confidence interval includes 0. Sobel and the confidence interval tend to match unless Sobel is close. And then bootstrapping tends to show you mediation, Sobel tends to lean away. That involves a lot of factors, actually, but that's usually what I see people reporting when they don't match. Right. So we would report this kind of like I have it on the bottom. The indirect effect, there's no symbol for it. You just call it the indirect effect. It's 106. Our bootstrapped, be sure you for bootstrapped 95% confidence interval is negative 0.01 to 0.12. So that includes 0, so likely no mediation has happened. So I think this next slide goes on to moderation, which we're going to take a break first. All that's going to be traditional mediation with some of the newer procedures. So let us take a brain break. Yay, brain break.